sure. You're gonna have to help me out, though. I don't know what quite that means.
I don't know. It's just because I don't have any problems for us to do. Do you have problems?
Well, let's see. Fortunately, you are the only honors geometry student I have. So I'm not sure that any of the problems I've gotten from my other geometry students would necessarily be appropriate for you. Let me think. Circles? First of all, tell me, do you just have a finals left, or do you have quizzes and a final, or what?
I have one quiz and one test, and then the final left.
And the quiz and the test are on what?
The quiz and the test are on chapter 10 in our book, so it's like find arc measures.
Okay. Okay.
Chords.
Right. Let me see if I have any problems here. Is there any way you can take a picture of those problems in your book and send it to me? Do we have the same book?
Maybe. It's like,
Are the authors of your book Larson, Boswell, and Stiff?
Yeah, and then it's like...
arcs and chords, okay. Alright. Yeah, arcs and chords.
You can look...
I definitely have a bunch of stuff on arcs and arc lengths. Want to do that?
Let's see if there are pictures.
I haven't had many people do anything on chords, but
here, I found like some work that I can do, I guess, extra.
Okay. What page? I'm looking in chapter 10.
712.
Now your pages are different than mine. Chapter 10 what? Subchapter what?
It just says chapter 10 test.
Okay.
I'm just gonna send a picture of these.
Okay. That's always the best thing to do. Because when I try to figure out what it is, sometimes I can't. I mean, it's slightly different, especially with an honors student. And, is that right side up or upside down? I think that's upside down. I figured out how to rotate it, incidentally. Got to download it first. Oh, it was right side up all along. Okay, hold on. Want to begin with 1?
Sure. Actually, those ones are easy.
Okay, well, pick where you want to begin.
Let's do 4.
All right. Tell whether the red arcs are congruent. Explain why or why not. Are they in 4?
Yes.
Okay, why?
Well, they're central angles and they're vertical angles, right?
Well, I don't know. Can you see that when I'm pointing?
No.
Can't see where I'm pointing at? Let me use my mouse.
Oh.
Can you see that?
Yeah.
Okay. The fact that that arc, AB, is 60 degrees means that that angle is 60 degrees. And the fact that that angle is 60 degrees means that that arc is 60 degrees. So you have a 60-degree arc and a 60-degree angle. So yes, because they're both 60-degree arcs, they're congruent. Now, number 5. About that one.
360 minus 224 is 136. So, yes, they are.
Yeah, because their central angles are the same. In other words, this central angle is 136, and that central angle, well, that arc is 136. And because this central angle is 136, it means this arc is 136. How about number 6?
Yes.
Well, they're certainly both 119 degrees, aren't they? Does that make them congruent? I think so.
Yeah.
Unfortunately, the book has the answers to just the odd ones, right?
Yes.
Okay. I think that that has to be true in the same way that if I have a 30-degree angle here and I have a 30-degree angle there, those two are congruent angles, even though they don't look, one looks bigger than the other. And same with this arc. As long as we're measuring that arc in degrees, the measurement of that arc, then that outside one is 119 and the inside is 119. Now tell me, is the arc length the same for both of those in number 6?
No.
No, the outside one is clearly longer than the inside one, because the arc length is a function of the radius, whereas the measurement of the arc is not. The measurement of the arc is a function only of that central angle. All right, let's see. Determine whether AB is a diameter. How about number 7, is it? Wow.
Yes.
You know what? That's a tough question.
Yes.
At first I said yes also, but you know what? It's not. You said yes because it's bisected, right? In other words, 8.9 is equal to 8.9.
Yeah.
Yeah, but it only is going to go through the center if it bisects both of these lines. In other words, if this was 9 and 9, then yes, that would have to be the center of the circle. But
not necessarily.
No, let me draw an extreme case.
But they're not asking if CD is a diameter, just AB. So if AB is dissecting the chord, if it dissects it, if it bisects it, then it...
No, you're absolutely right. You're absolutely right. Yeah, the diameter always bisects a chord. So yeah, no, I was looking at it, I was thinking of CD. And what I was going to draw was a chord like that that was bisected by this, and make that say 5 and make that say 5, and then clearly that is not a diameter and yet still bisected. But you're right, they're asking about AB, and the fact that AB is bisected by that makes it a diameter. How about number 8?
Yes.
Same reason. Same reason. It bisects the chord CD, just like number 7. How about number 9?
Number 9, AB.
Yeah.
Yeah.
Clearly we have to do a little bit more work on number 9. Let's see if we can draw a picture of number 9. The way they drew it, it certainly does not look like it's a diameter, but until we put some numbers on it, we're not really going to know. You can't assume that they're going to draw it to scale.
Wouldn't we need to do 2025 or a squared plus
We
20?
need to figure out that distance right there, correct?
Mm-hmm.
If it's not 14, then AB is not a diameter.
Mm-hmm.
What kind of triangle is that?
A right triangle.
What else about it looks familiar?
Oh, it's a 3, 4, 5.
Okay, so it's a multiple of a 3, 4, 5. So what's this side going to be?
12.
15.
15. Why 15?
Well, because this is 3 times 3.
Oh. I did it wrong. Yeah.
No, hold on. Am I wrong?
No, you're right. Because that's 3 times 5, that's 4 times 5, and that's 5 times 5.
There you go. Either answer, 15 or 12, would prove that AB was not a diameter, but it is 15. And you're going to find that 3, 4, 5 triangles are everywhere, or multiples of them. And recognize them is really quite useful because you can solve them so much quicker rather than plugging them into the Pythagorean formula. Number 10. What's ABC? The measurement of ABC angle.
$53.
Okay, how about number 11, the measurement of arc DF?
$164.
Number 12, the measurement of arc GHJ.
GHJ.
Huh?
So then that's 86, and then 360 minus 86 is 274.
That's right, okay. Number 13, measurement. Go ahead. You have a question?
He's confused me.
Number 13?
Yeah, the tangent.
Yeah, in other words, the difference is that number 10, 11, and 12 were all intersecting chords, whereas number 13 is a tangent line and a chord. Well, the rules are the same.
It's a 2-to-1 relationship.
Yeah. In other words, angle 1 is half of 238.
So 122 divided by 2.
No, 238 divided by 2.
But isn't it asking? Oh, it's not asking.
Yeah. Let's talk about this. Let's talk about this because this is an easy way to forget, or an easy one to forget.
Asking about.
And yet, I can give you a way to always.
I was thinking.
I can give you a way to always.
Other side.
Okay. If this is the same rule as 2 secants, or 2 chords rather, then angle 1 is going to be half of that, which would be 119. Okay, as long as this is 238 from there to there. Well, let's see if this makes sense. The one thing we know for sure is that angle 1 is supplemental to the angle next to it, correct?
Mm-hmm.
So the angle next to it is 61 degrees. And what is the arc, the measurement of this arc? If this one is 238, what's this one? subtract that from 360.
122.
Yeah, 122, which would make this angle 61, which it is. So we have to have done everything correctly. In other words, if you forget as to, well, how do you handle a chord with a tangent line, it's the same exact logic as handling two chords. Whatever this measurement of the arc is, this angle is half of that. And this proves it, because we know those two angles have to be supplementary, and we know that the complete circle has to add to 360. All right. Number 14. We have two intersecting chords subtending two different arc lengths. In other words, we have the chords not intersecting anywhere near the center, and certainly not intersecting the same arc measurement. And we need angle 2, and this one is 112, and this one's 52. So first of all, it's important to realize that angle 2 is the same as what angle?
Is 1.
Okay. Which means that there cannot be a direct relationship between angle 1 and this 52 degrees, because it's the same measurement as angle 2, and this thing says 112. So angle 2 must be some combination of 52 and 112. Well, what would you think it would be? Let's play around with it and see what makes sense. And we know it's either half or double, right? Everything with circles is either half or double.
Well, that should be half.
Yeah, and let's see if it is.
Oh, isn't it just, wait,
52 plus 112 is 164. Divided by 2 is 82. Well, if it has to be either half or double, that's awfully close to looking like an 82 degree angle. That means we're correct, that it was half. It's not double, and nothing's a, well, I shouldn't say nothing's a third. There are some,
right.
but
When you're inside the circle, then you have to add them. When you're outside, you subtract them.
yes, exactly. But you could figure that out without memorizing it. And that's what I'm kind of trying to help you do. Because it's real easy to have our memories go on some of these obscure circle problems. And I can tell you right now that this is not anything you need for the ACT or the SAT test. It's just taught in geometry. Okay? So it's real easy to forget these relationships. But as long as you remember that with most all of these circle problems, it's either double or half, and it's either added or subtracted. In other words, the case you were referring to where it's subtracted is when you have something like this.
Yeah.
Angle 1 has to do with the measurement of that arc and the measurement of that arc. And this is where you subtract the bigger one minus the smaller one, and it's half of that. All right, let's get back in order here. Let's see. Which one did we just do? We just did 14?
Yeah.
Yeah, and notice they don't ask us to solve for the other angle because immediately we know that 2 is the same as the angle it's vertical with. So 2 equals half of 164, 82 degrees. Okay, good. That's right, I already did that. 15. Now, the situation where I just drew like this, that's very, very similar to 15. Even though they give you a different angle, or they give you a different formula, let's say that instead of having 2 intersecting secant lines, one of them is tangent. Well, it's still the same formula. In other words, this angle, theta, is going to be that arc measurement from there to there minus the arc measurement from there to there divided by 2. So in this problem, they give us this angle, and they give us the outside angle.
So it should be 168 minus x equals 42.
Half of that.
Yeah.
What do you get?
So 168.
You said it exactly right. 168 minus x, which we're trying to figure out, the measurement of arc AC, divided by 2 has to equal 42. Now it's an algebra problem.
So 63.
Well, 168 equal or minus x equals 84. Move the x over, move this over. I get 84.
Oh, I see what I did. I divided after.
Now, does 84 make sense? In other words, you're always asking, 2 years from now, when you're trying to remember these, you may not remember whether you have to divide by 2 or not. Okay? Let's say we didn't divide by 2. X would have come out to be 166. Or not X, but AC. Well, you can look at that. That would be more than a third of the circumference. Could that possibly be X would come out to be 126, which is still a third of the circle. Could that be an arc of 126 AC? No. In other words, here, let's talk about circles. And these ballpark tests are very important, I feel. If I'm dividing a circle up into thirds, then each of these arcs is 120 degrees. Okay? So for me to look at that arc and come up with an answer of 126 degrees doesn't make sense. That is less than a third of the circumference. Therefore, what I must have done was forgot to divide by 2. Once I divide by 2, I get an answer of 84 degrees, which makes much more sense looking at the picture, that it would be 84 rather than 126. So I think it's always worth doing a ballpark check on all math problems if you can do it. It frequently will tell you whether you have memorized the original equation or not properly. All right, let's do one more. On 16, what's the equation I can write?
16 times 4 equals 8 times x. Right?
14 times 4?
Yeah.
Yes. Equals 8 times x. And then just solve that. On number 17, what's the equation I can write?
12 squared equals 9 times 9 plus x.
Good. Got these memorized good. And on number 18, what's the equation I can write?
20 times 20 plus 32 equals x times x plus 28.
Correct. And some of those are going to yield a quadratic, and when you solve for it, you may get a positive and negative answer. Well, clearly when you're talking geometry and you're talking dimensions, you don't have negative dimensions. So any negative x that might come out of solving that equation, you discard and only use the positive ones. That was good on those last three. You got those memorized good. Glad we waited till the end on those. All right. Quaid, I will talk to you next time.
Alright, thank you.